Okay, let's do one more round of improvements on our word count script. We're gonna now sort the results the way that we want, and doing that's a little bit tricky, so let's walk through how that's gonna work. Okay, so the last thing we need to do is to sort our results of word count by something useful. So instead of just having a random list of words associated with how many times they appear, what we want to do is get the least used words at the beginning of our list and the most used words at the end, and that should give us some actually interesting information to look at. So to do this, we're going to need to manipulate our results a little bit more directly, so we can't just cheat and use count by value and call it done. So first thing we're going to do is actually implement what count by value does by hand the hard way, so we can actually play with the results more directly and stick the results in an RDD instead of just getting a Python object that we need to deal with at that point. So the way we do that is we take our map of words and we use a mapper that just converts each individual word into that word and the value of 1. And this is a very similar trick to what we did in the earlier script where we computed the average number of friends by age in a fake social network, where we just use that extra number 1 there as a way to count up how many times something occurs. So then when we call reduce by key, our keys here are the individual words, and for every time that word occurred, the number 1 will get added in as part of the reduction. So we're passing in a lambda function that just says add these two things together, and by doing so we'll end up getting values that just keep adding up, 1 plus 1 plus 1 plus 1 for however many times that word occurs. So keep in mind, just to walk through it one more time, we're starting off with a plain old RDD that contains words, every word that appears in the book. We are then mapping that so that every word is instead a key value pair of the word and the number 1. We then reduce that by key, so we aggregate together every time that each individual word appeared, and we use this lambda function to say we're just going to add the values together for each individual key. So that just keeps adding up 1 plus 1 plus 1 plus 1 for however many times that word appeared. So that has the same effect as count by value, except the result gets stored in a new RDD called word counts instead of a Python object that we need to then manipulate. Make sense? If not, hit pause, stare at this some more. Like I said, it's a very similar trick to what we did in an earlier example, so hopefully that makes a lot of sense. Now, what we have at this point is an RDD that has words and the number of times they appear in it, but we want to sort by the number of times each word appears. So before we sort, we need to flip that around. So we're just going to map things so that our keys becomes values and our values become keys. So we start off with the keys being the words and the values being the numbers of time that word occurred. We're going to flip that around in this mapper and make that instead the number of times it occurred followed by the word itself. And then we can chain together a call to sort by key to sort the final RDD that we store in word count sorted by the number of times it occurred. Okay? Makes sense? It's pretty straightforward. We're just flipping things around so we can sort it the way that we want to. Let's take a look at the code. Okay, let's do our last little improvement to our word count script. So usually this is a really simple example in most textbooks, but we're going to make it something a little bit more interesting. So if you haven't already, go to the resources for this lecture and download word count better sorted.py, and let's open that up in your favorite Python editor. All right, so what have we done differently here? Well, we talked about it in the previous slide, so here it is all together. Basically, instead of just cheating and calling count by value, we're going to actually do that by hand. So we're going to do a mapper where we're going to transform every word into a key value pair of the word and the number 1. And then we reduce by key, where we just add them all up. So for every unique word in our words map from our words RDD, we'll add up every instance using this addition lambda function, and we end up with a key value RDD where the keys are the words and the values are the number of times that word occurred. Now we're going to flip that key value pair around so that the key is the count and the value is the word, and then we can sort by key to get a sorted list by the number of times each word occurs. Finally, we'll just grab the results through a collect action. That'll kick everything off to actually execute, and we'll go out and print out in a slightly different format just the word followed by a colon, couple of tabs, and the count. So let's go ahead and run that and see it in action. Spark-submit. Word count better sorted.py. And this should look a little bit better, a little bit more useful, a little bit more interesting. Let's see what comes up. All right, so indeed, we are sorted by the number of times each word occurred, and the most popular word in my book is the word you. Wow, I must be quite the egomaniac. Oh no, wait, you. It's not me. It could be worse. It's not me. It's you. That's a good thing. To, your, the, a, of, and that. All the words you'd expect to show up a lot in any book, really. And when we start to get into more interesting words, business turns out to be the most popular word, which makes sense because it is, in fact, a book about starting your own business. Now, I do want to point out a couple of bad things here, though. The S is not a word, and what's up with that? So, well, our regular expression isn't perfect for breaking up words. It turns out that it was probably splitting out the S from contractions like its or Frank's, apostrophe S things. So the S got split out into its own word. So, if you did want possessive forms of a word to count as different words, that would be an issue. And also you want to make sure you account for weird results like that when you're analyzing your results. Again, a more sophisticated natural text language processing toolkit like NLTK would do a better job of that, but it's kind of overkill for what we're trying to do. But it's a good lesson in that your results in data mining or machine learning are often, well, they're always only as good as your input data, right? So a big part of getting good, meaningful, actionable results out of any data analysis you do is going to depend a lot on your ability to clean the data that you're using beforehand into the form that you want. So always look at your results skeptically and be on the lookout for weird things like S and T just showing up, because that's just coming out of contractions, it turns out. Anyway, a little bit of a digression there onto machine learning and data mining in general. Always make sure you clean your data. It's just as important as everything else. All right, and with that, we have a pretty good word counter script. We've actually gotten rid of at least the most egregious forms of splitting on things incorrectly, and we've sorted it by useful results. So, hooray! Let's move on to our next set of examples. All right, I'm pretty happy with those results all in all. We got some real insights into the nature of this book by studying the words that are most frequently occurring in it. So, it's looking pretty good. It's not perfect, but hey, it's good enough for my needs. We've learned a lot along the way here. We've learned about flat map versus map. We've learned about some sorting tricks that you can do with RDDs. And we've learned about, different ways of dealing with regular expressions to cleanse text data. So that's kind of a quick and dirty way to handle some text processing tasks that you might run into in the future. We are collecting a pretty good collection of scripts here. So, make sure you keep everything in your Spark course directory somewhere safe. There's going to be a lot of useful examples in there that you're going to want to refer to again later on, I suspect. So let's move on.